Welcome. This recording of 200 Ways to Pass the Chemistry Physical Setting Regents exam is meant to be used by those students wishing to improve their scores on the New York State Chemistry Regents exam. It is not meant to be used for entertainment purposes. It may be used as a subliminal or a direct study aid. Warning: it is advisable that you do not listen to this recording while driving, as it may cause drowsiness. Let's begin. 200 Ways to Pass the Chemistry Physical Setting Regents exam. 1. Protons are positively charged. 2. Neutrons have no charge. 3. Electrons are small and are negatively charged. 4. Protons and neutrons are in an atom's nucleus and are sometimes called nucleons. Protons and neutrons have the same mass value. 5. Electrons are found in clouds or orbitals around an atom's nucleus. 6. The mass number is equal to an atom's number of protons and neutrons added together. 7. The atomic number is equal to the number of protons in the nucleus of an atom and is unique for each element. 8. The number of neutrons equals the mass number minus the atomic number. 9. Isotopes are atoms with equal numbers of protons, but differ in their neutron numbers. 10. Cations are positive ions and form when a neutral atom loses electrons. They are smaller than their parent atom. 11. Anions are negative ions and form when a neutral atom gains electrons. They are larger than their parent atom. 12. Ernest Rutherford's gold foil experiment showed that an atom is mostly empty space with a small, dense, positively charged nucleus. 13. J.J. Thomson discovered the electron and developed the plum pudding model of the atom. He theorized that negative particles were spread throughout a positive atom. 14. Dalton's model of the atom was a solid sphere of matter that was uniform throughout. 15. The Bohr model of the atom placed electrons in planet-like orbits around the nucleus of an atom. 16. The current wave-mechanical model of the atom has electrons in clouds or orbitals around the nucleus. This modern model of the atom is sometimes called the orbital theory model of the atom. 17. Remember, use your reference table. 18. STP means standard temperature and pressure. You can find these values on Table A of your reference table. It is 273 degrees Kelvin and 1 atmosphere. 19. Electrons emit energy as light when they jump from higher energy levels back down to lower or ground state energy levels. Excited state electrons are naturally unstable and will seek to return to ground state. When this happens, a bright line spectra is produced. 19.b. Bright line spectra can be used to identify individual elements, as they are unique to each element. 20. Elements are pure substances and are composed of only one kind of atom. 21. Binary compounds are substances made up of only two kinds of atoms. For example, H2O contains only hydrogen and oxygen. NH3 contains only nitrogen and hydrogen. CO2 contains only carbon and oxygen. 22. Diatomic molecules are elements that form two atom molecules in their natural form at standard temperature and pressure. Remember the phrase Brinkelhoff, which stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These elements will never be found alone in their natural state. If they are unbonded to another different atom of another element, they will always be bonded to another copy of themselves. 23. Remember the number of significant figures in a measured value. Remember the rules for significant figures in a measured value. Leading zeros are never significant. All numbers that are not zero are always significant. Trailing zeros are only significant when a decimal point appears in the number. Trapped zeros are always significant. 24. Solutions are the best examples of homogeneous mixtures, such as air or salt water. A homogeneous mixture is defined as a mixture in which all the particles are evenly distributed throughout. 25. Heterogeneous mixtures have discernible components and are not uniform throughout, such as chocolate chip cookies, vegetable soup, soil, muddy water, ocean water, etc. 26. A solute is the substance being dissolved, while the solvent is the substance that dissolves the solute. Water is the solvent in Kool-Aid, while sugar is the solute. 27. Isotopes can be written in a number of ways. C-14 is also carbon-14 and is also written as mass number 14 above atomic number 6 to the left of a C for carbon. 28. The distribution of electrons in an atom is its electron configuration. This information can be found on the periodic table. 29. Electron configurations are written in the bottom center of an element's box on the periodic table in your reference table. The last level of any electron configuration consists of the valence electrons. 31. Valence electrons are the last level of an atom's electron configuration. They are the atom's electrons that are involved in bonding. 32. Polyatomic ions are groups of atoms that behave as one with an overall charge. These are found on Table E, such as nitrate, ammonium, sulfate, etc. 33. Coefficients are written in front of the formulas of reactants and products in chemical equations. They give us the ratios of reactants and products in a balanced chemical equation. They are generally equitable to the number of moles of an atom or a compound involved in a reaction. 34. Chemical formulas are written so that the charges of cations and anions neutralize one another. Please remember your criss-cross rule for formula writing. Remember that if you are adding an additional subscript outside of a polyatomic ion, that polyatomic ion must be written in parentheses. Consider consulting Table I for examples. 35. When naming binary compounds, write the name of the positive ion or cation first, followed by the name of the negative ion or anion with the name ending in "ide" or IDE. For example, KCl would be potassium chloride. MgS would be magnesium sulfide. 36. When naming compounds containing polyatomic ions, keep the name of the polyatomic ion the same as it is written in Table E. For example, NH4Cl is ammonium chloride. NH4NO3 is ammonium nitrate. 37. Physical changes do not form new substances. They merely change the appearance of the original material, such as the melting of ice. 38. Chemical changes result in the formation of new substances, such as the burning of hydrogen gas to produce water vapor. 39. Reactants are on the left side of the reaction arrow, and products are on the right. Think of it as a recipe. Reactants are your ingredients, and products are what you get at the end. 40. Endothermic reactions absorb heat. The energy value will be on the left or reactant side of the reaction arrow in a forward reaction. 41. Exothermic reactions release energy, and the energy is a product in that reaction. 42. Only coefficients can be changed when balancing chemical equations. 43. Synthesis reactions occur when two or more reactants combine to form a single product. 44. Decomposition reactions occur when a single reactant forms two or more new products. 45. Single replacement reactions occur when one element replaces another element in a compound. For example, magnesium reacting with hydrochloric acid yields magnesium chloride plus hydrogen gas. 46. Double replacement reactions occur when two compounds react to form two new compounds. 47. The masses of the reactants in a chemical equation are always equal to the masses of the products. This is the law of conservation of mass. Remember, in any chemical equation, mass, charge are conserved. 48. The gram formula mass of a substance is the sum of the atomic masses of all the atoms in it. This is sometimes called the formula mass. This formula is not on Table T. 49. Know how to calculate percent composition of a compound. This formula is on Table T. 50. 6.02 times 10 to the 23rd is called Avogadro's number and is the number of particles found in 1 mole of a substance. 51. The particles in a solid are rigidly held together. Solids all have a crystal structure. 52. Solids have a definite shape and volume, heat absorbed or released by substances. If your problem references a temperature change, use the formula Q equals mc delta T, where Q equals heat, m equals mass, C equals specific heat capacity of the substance. If this is water, it is 4.18 and can be found on Table B. Delta T represents the temperature change in degrees Celsius or Kelvin. 61. The heat absorbed or released when 1 gram of a substance changes between the solid and the liquid phases is the substance's heat of fusion. This value is 334 joules per gram. For water, this is found on Table B. If you are calculating the heat either released during freezing or absorbed during melting, you must use Q equals M HF, or heat of fusion. 62. The heat absorbed or released when 1 gram of a substance changes between the liquid and the gas phases is the substance's heat of vaporization. This is 2,260 joules per gram for water. This value can be found on Table B. If you are calculating the heat absorbed during a phase change of a liquid to a gas, or released when changing from a gas to a liquid, you must use Q equals M H sub V, or heat of vaporization. Remember, it takes more energy to vaporize a substance than it does to fuse it. 63. As the pressure on a gas increases, the volume decreases proportionally. This is an inverse relationship. 64. As the pressure on a gas increases, the temperature increases. 65. As the temperature of a gas increases, the volume increases. 66. Remember, if you are using the combined gas law formula as found on Table T, your temperature must always be entered in degree Kelvin. This formula is used for calculating changes in pressure, volume, and temperature between starting conditions and ending conditions. It reads as P1 times V1 over T1 equals P2 times V2 over T2. 67. Real gas particles have volume and are attracted to one another, and thus do not always behave like ideal gases. Real gases will behave more like ideal gases at low pressures and high temperatures. You can remember this by using the word plight. Pressure low, ideal gas, high temperature. Remember, real gases will behave more like ideal gases if they are exceedingly small in volume. Thus, hydrogen and helium are the 2 real gases that can behave most like an ideal gas. 69. Distillation separates mixtures with differing boiling points. 70. Filtration separates mixtures of solids and liquids. Filtration can be used to separate the components of a heterogeneous mixture. Distillation can be used to separate components with differing IMFs. Remember, a higher boiling point indicates stronger IMFs. 71. Chromatography can also be used to separate mixtures of liquids and mixtures of gases. Chromatography separates both based on molecule size and molecule polarity or solubility. 72. The periodic law states that the properties of elements are periodic functions of their atomic numbers. 73. Periods are horizontal rows on the periodic table going from left to right. The period of any element indicates its number of electron shells. 74. Groups are the vertical columns on the periodic table. For all elements outside of the transition metals, which are groups 3 through 12, the group number indicates the number of valence electrons for that element. 75. Metals are found on the left side of the periodic table, to the left of the staircase. Nonmetals are above the staircase to the right. Metalloids directly border the staircase. 76. Remember, metals are malleable, ductile, lustrous, good conductors of both heat and electricity as solids. They have low ionization energy and low electronegativity. They tend to form positive ions. They conduct both heat and electricity because they have mobile valence electrons. Nonmetals, on the other hand, are brittle when solid. Most of them are gases at standard temperature and pressure. They are dull. They are good insulators. Thus, they are poor conductors. They have high ionization energies and high electronegativities. They tend to form negative ions. 77. Noble gases are inert and stable due to the fact that their valence level of electrons is completely filled. Noble gases are found in group 18. They all have 8 valence electrons in their outer shell, giving them a full stable octet. 78. Ionization energy increases as you go up and to the right on the periodic table. Ionization energy measures an atom's tendency to lose electrons. Atoms that lose electrons more easily will have a low ionization energy because it will take less energy to remove their most loosely held outer valence electrons. 79. Atomic radii decrease from left to right across a period due to increasing nuclear charge. This means there is a greater attraction between the positive protons in the nucleus and the negative valence electrons outside it. 80. Atomic radii will increase as you go down a group because you are adding shells. 81. Electronegativity is a measure of an element's attraction for another element's electrons in a bond. Electronegativity is easily remembered in that fluorine has the highest electronegativity of any element. It is found in the top right corner of the periodic table. Francium has the lowest electronegativity. It is found in the lower left corner. So 82, electronegativity increases as you go up and toward the right on your periodic table. 83, elements in group 1 are alkali metals. 84, the elements in group 2 are alkaline earth metals. 85, the elements in group 17 are halogens. 86, the elements in group 18 are noble gases. 87, use table S to compare and look up the properties of specific elements if you are asked to define a periodic trend. 88, energy is released when a chemical bond forms. Energy is absorbed when a chemical bond is broken. The more energy that is released on formation, the more stable the bond will be. A way you can remember this is BARF, where B stands for breaking, A absorbed, R released, F formed. 89. The last digit of an element's group number is always equal to its number of valence electrons. 90. If you are drawing a Lewis dot diagram, draw one dot for each valence electron from an element, and only valence electrons. 91. The kernel, with a K, of an atom includes everything in an atom except the atom's valence electrons. In a Lewis diagram, the kernel is represented by the symbol for the element, such as C standing for carbon. 92. Metallic bonds are thought of as a crystalline lattice structure of kernels surrounded by a sea of mobile valence electrons. Only metals have metallic bonding. If you are asked to identify a metallic bond, choose the metal. 93. Atoms are most stable when they have 8 valence electrons, an octet, and tend to form ions to obtain such a configuration of electrons. 94. Covalent bonds form when 2 atoms share a pair of electrons. 95. Ionic bonds form when one atom transfers an electron to another atom when forming a bond with it. 96. Non-polar covalent bonds form when 2 atoms of the same element or very close electronegativity bond together. 97. Polar covalent bonds form when the electronegativity difference between 2 bonding atoms is between 0.4 and 1.7. Table S can always be used to calculate the electronegativity difference between 2 atoms in a bond. 98. Ionic bonds form when the electronegativity difference between 2 bonding atoms is greater than 1.7. This very large electronegativity difference is what allows the more electronegative element, usually the nonmetal, to steal the electrons of the less electronegative element, usually a metal. 99. Substances containing mostly covalent bonds are called molecular substances. Remember, the word molecular is code for covalent. 100. Substances containing mostly ionic bonds are called ionic compounds. These are sometimes referred to as formula units. 101. The properties of ionic and covalent substances are important. Remember, ionic substances are hard, have high melting and high boiling points. They conduct electricity when molten or when aqueous, which means dissolved in water, but they never conduct electricity as a solid. Ionic substances conduct electricity because when they are aqueous, their ions dissociate and become mobile. Covalent substances, or molecular substances, are soft. They have low melting and low boiling points, and they do not conduct electricity. 102. Hydrogen bonds form when hydrogen bonds to the element nitrogen, oxygen, or fluorine, and gives the compound containing it unusually high melting and boiling points. Hydrogen bonds are a type of intermolecular force of attraction, or IMF. They are the strongest IMF. They are not actually a bond. 103. Use Table F to predict the solubilities of compounds. Remember, the left side shows you soluble rules. The right side shows you insoluble rules. Both columns include exclusions. You must check these. 104. Remember, substances tend to be soluble in solvents with similar properties. Like dissolves like. Thus, polar substances will dissolve in other polar substances. Water is the most common polar solvent. 105. As temperature increases, solubility increases for most solids. This is shown on Table G as lines which will slope upwards. 106. At low temperatures and high pressures, solubility will increase for most gases. Remember the conditions necessary to keep a soda fizzy in a bottle. 107. Use Table G to determine whether a solution is saturated, unsaturated, or supersaturated. If a solution is saturated, For any combination of mass of solute and temperature, the point will be found on the line for that substance. If it is unsaturated, it will be below the line. If it is supersaturated, it will be above the line. Unsaturated substances can hold more solute. Saturated substances are holding as much solute as possible. Supersaturated substances are holding more solute than is reasonably possible and will quickly crystallize if given a chance. 108. Molarity is a way to measure the concentration of a solution. This formula is found on Table T. Molarity is equal to the number of moles of solute divided by the number of liters of solution. 109. Percent by mass equals mass of the part divided by mass of the whole times 100. Always check to see if you are being given information about two parts, which will need to be added together in order to achieve the whole value. 110. Parts per million equals grams of solute divided by grams of solution times 1 million. This is found on Table T. 111. Solutes raise the boiling points and lower the melting points of solvents. What is high gets higher, what is low gets lower. This is dependent on the number of particles of solute dissolved, so consider both concentration and the formula of the solute dissolving. 112. Liquids will boil when their vapor pressure is equal to the atmospheric pressure. This corresponds to the 101.3 kPa dotted line found on Table H. 113. The normal boiling point of a substance is the temperature at which it boils at 1 atmosphere of pressure. Once again, take note of Table H. 114. Covalently bonded substances tend to react more slowly than ionic compounds. This is because of their size. 115. Increasing the concentration of reactants will increase reaction rate. 116. Increasing the surface area of the reactants will increase the reaction rate. 117. Increasing the pressure on gases increases the reaction rate. This is due to collision theory, the idea that increasing the pure number of collisions will increase your chances for effective collisions, which result in a chemical reaction. An effective collision must always occur in the proper orientation and with the correct amount of energy. 118. Catalysts speed up reactions by lowering their activation energies. They are not changed themselves and can be reused many times over. 119. Increasing temperature will increase reaction rate. Please review and be able to recognize your potential energy diagrams. A potential energy diagram shows you the amount of energy in the reactants and the products for a reaction. It also shows you the necessary activation energy in order to go from the reactants to the products in the reaction coordinate. In an exothermic potential energy diagram, the energy in the reactants will be greater than the energy in the products. Thus, energy is released when going from the reactants to the products. In an endothermic or uphill potential energy diagram, the reactants start with less energy than is found at the end in the products, and thus the amount of energy required to force the reaction to occur is much greater. This is an endothermic reaction, and the delta H value will be positive. 121. delta H is positive for endothermic reactions and negative for exothermic reactions. This is also found on Table I. 122. The rates of the forward and reverse reactions are always equal at equilibrium. At equilibrium, the concentration of any reactants and any products in an equilibrium system will be constant. 123. Adding any reactant or product to a system at equilibrium will shift the equilibrium away from the added substance. 124. Removing any reactant or product from a system at equilibrium will shift the equilibrium toward that removed substance. This refers to Le Chatelier's principle in the idea that any stress to an equilibrium system will create a change in order to relieve that stress and return the system to equilibrium. 125. An increase in temperature shifts an equilibrium system in the endothermic direction. 126. A decrease in temperature shifts the equilibrium system in the exothermic direction. 127. Increasing the pressure on a gaseous equilibrium will shift the equilibrium point toward the side with fewer moles of gas. This only affects gaseous systems. 128. Decreasing the pressure on a gaseous equilibrium will shift the equilibrium point toward the side with more moles of gas. Once again, this only affects gaseous systems. 129. Catalysts will have no effect on an equilibrium. It will just establish itself quicker. 130. Enthalpy H is the heat energy gained or lost in a reaction. 131. Entropy S is high in a highly unorganized system, such as a gas, a messy room, a system in which temperature has increased. Entropy is disorder. 132. Oxidation is the loss of electrons by an atom or an ion. The oxidation number will increase as a result. Electrons in an oxidation will always be shown on the right side of the reaction arrow. 134. Reduction is the gain of electrons by an atom or an ion. The oxidation number decreases or is reduced as a result. The electrons are on the left side of the reaction arrow. 135. Redox reactions always involve the exchange of electrons. 135.b. Any free state atom or unbonded atom has an oxidation number of 0. 136. Remember, oil rig. Oxidation is losing, reduction is gaining. 137. Identify redox reactions by seeking an uncombined element on one side of the reaction that is in a compound on the other side. This describes a single replacement reaction. 138. Oxidizing agents are what gets reduced in a redox reaction, and reducing agents are what get oxidized in a redox reaction. Remember, metals on table J are more easily oxidized if they are closer to the top. Nonmetals are more easily reduced if they are closer to the top of table J. You can determine which element is most likely to be oxidized by looking for which metal is higher on table J. 139. Electrochemical cells or voltaic cells produce electricity from chemical energy with a spontaneous redox reaction. You will know if a redox reaction is spontaneous if the free state element in the reaction is higher on table G than the bonded element of the like kind. 140. The left electrode is often the site of oxidation in an electrochemical cell diagram, but not always. Always check table J. 141. Remember, anox. The anode is always oxidation. Red cat. Reduction is always at the cathode. Fat cat. Electrons always flow from the anode to the cathode. 142. An electrolytic cell, or an electroplating cell, such as what we built in class, uses an applied electrical current to force a non-spontaneous redox reaction to take place. Without this energy source, no reaction would occur. 143. Electrolytic cells are usually used for the metal plating of objects. 144. Acids and bases are both good electrolytes. Their solutions conduct electricity well. To remember your electrolytes, use the word ABS, acids, bases, and salts. 145. Weak acids taste sour. 146. Bases taste bitter. 147. Acids and bases will turn indicators different colors. These are listed on Table M. Remember, the middle column of Table M shows you the range of the shift of the color. To the left of that pH value, the shift is the first color. To the right of that pH value, the shift is the second color. Between and in the shift, the colors are blended. 148. Acids have a pH less than 7. 149. Bases have a pH greater than 7. 150. Tables K and L list the names and formulas of common acids and bases asked about on the Regents. Remember, acids release hydrogen, bases release hydroxide. Bases on Table L are generally metals plus a hydroxide. 151. All the metals above hydrogen on Table J will react with acids to produce hydrogen gas bubbles. 152. Arrhenius acids give off hydrogen ions or hydronium ions in solution. Both of these ions are positive. Bases give off negative hydroxide or OH ions in solution. 153. The Bronsted-Lowry or alternative theory of acids and bases states that acids will donate protons and bases will accept protons. You can remember this by add-ba. Acids donate, bases accept hydrogen. 154. Acids and bases react in neutralization reactions to create a water and a salt. Water and an ionic salt will always be the product of a neutralization. 155. Titrations are controlled neutralization reactions used to find the concentration of an acid or a base sample. The formula is on Table T. 156. All organic compounds contain carbon. 157. Carbon always makes 4 bonds. 158. Saturated hydrocarbons have all single bonds within them. These are alkanes. Use reference table Q. 159. Unsaturated hydrocarbons have double or triple bonds in them. These are alkenes and alkynes. Use Table Q. 160. Hydrocarbons contain only the elements hydrogen and carbon, nothing else. 161. The homologous series of hydrocarbons formulas for alkanes, alkenes, and alkynes are found on reference table Q. The prefixes, which indicate numbers of carbons, are found on table P. 162. The functional groups on organic molecules are listed on reference table R. Use reference table R and its naming examples to draw any necessary organic molecules. 163. Structural isomers of organic compounds have different structural formulas, but the same molecular formula. 164. Number the parent carbon chain in an organic molecule from the end closest to an alkyl group or functional group. You want the lowest numbers possible. 165. Combustion reactions occur when a hydrocarbon reacts with oxygen to make carbon dioxide and water. Combustion reactions only produce carbon dioxide and water. The first 5 reactions on table I show combustion reactions. 166. Organic substitution reactions occur when an alkane and a halogen from group 17 react so that one or more hydrogen atoms on the alkane are replaced. 167. Organic addition reactions occur when an alkene or an alkyne combine with a halogen to make one product. These are known as halides. 168. Esterification occurs when an organic acid and an alcohol react to make water and an ester. Please check these substances on table Q. Remember, esters are often used as flavorings or odors for foods. 169. Saponification occurs when an ester reacts with a strong base to make an alcohol and a soap. 170. Fermentation reactions occur when yeast catalyze the production of a sugar to make carbon dioxide and ethanol. 171. Polymers are long chains of repeating units called monomers. 172. Polymers form through polymerization reactions. 173. Addition polymerization occurs when unsaturated monomers join in a long polymer chain. 174. Condensation polymerization occurs when monomers join to form a polymer by removing water. Water is always a product in a condensation polymerization. 175. Natural polymers include starch, cellulose, and protein. 176. Synthetic polymers include plastics such as nylon, rayon, and polyester. 177. Unstable atoms that are radioactive are called radioisotopes. Common radioisotopes are found on table N. 178. Radioisotopes can decay by giving off any of the particles or emanations listed in table O. 179. Alpha particles are positively charged and have a mass of 4. Beta particles are negatively charged and have no mass. Positrons have a mass of 0 and are positively charged. All of these particles are found in table O. 180. The sum of the mass numbers and atomic numbers must be equal on both sides of the reaction arrow for a nuclear equation. 181. Fission reactions split heavy nuclei into smaller ones. If a neutron is involved in a nuclear reaction, It is probably a fission reaction. 182. Fusion reactions occur when light nuclei, such as hydrogen or helium, combine to form a heavier nucleus with a lot of energy. Remember, nuclear reactions produce the most energy of any type of reaction we have learned about. The amount of energy produced in a nuclear reaction is defined through Einstein's theory of relativity, E equals mc squared. 183. The half-life of a radioisotope is the length of time it takes for 1/2 of the atoms in a sample to radioactively decay. The half-lives for common radioisotopes are found on Table N. Remember, radioisotopes are radioactive because they have an unstable neutron-to-proton ratio. 184. Carbon-14 is used to determine the ages of organic or once-living materials up to 23,000 years old. 185. Uranium-238 is used to determine the ages of rocks. 186. Iodine-131 is used to treat thyroid disorders. 187. Cobalt-60 is used to treat cancer tumors. 188. Radiation can be used to kill bacteria on foods to slow the spoilage process. 189. Disposal of radioactive waste is a major problem associated with nuclear reactors. Remember, radioactivity, even when used in a medical setting, is always a danger in that it could cause mutation or damage to healthy cells or tissues. 190. Remember to use your reference tables. 191. Answer every question. If you don't know the answer, take a guess. Some chance of getting it right is better than none at all. 192. You have 3 hours to take the test. Take your time. 193. Try substituting words that might seem confusing with a different word. Sometimes this makes the question make more sense. For example, substitute the word false for not true. 194. Consider on every question if the answer could be in the reference table or if the reference table could help you. 195. Your first choice is often your best one. 196. Even if you think you know a formula with great confidence, look it up. Most of them are on Table T. 197. When you receive your Regents exam, do a memory dump. On the front page or the back of your exam, immediately write down all those things you are afraid you might forget. Then open the test and begin. 197. Skip a question if it's giving you a hard time. Go back to it later. Something else in the test may help you answer that harder problem. 198. Eat a healthy meal the night before your test and for breakfast as well. Stay hydrated. 199. Get a good night's sleep. Do not stay up all night studying. A tired mind is never as sharp and clear as a well-rested one. 200. Relax. You've seen this stuff all year.